Good morning, everyone. Today we can discuss about the next module, which includes register transfer logic, different types of micro operations, and what you mean by a processor organization, how arithmetic unit is organized, what about the shift register and status register. So first we can study register transfer logic. So for describing a digital system in terms of functions such as adders, decoders, and registers, actually a method is used that is known as a register transfer logic. Registers are selected as the primitive components of the system and they are the smallest memory. So the register transfer logic uses a set of expressions and statements which compare the statements used in the programming language. How the transfer of data is in between the register is happen. It can be expressed by using a register transfer logic. So നമുക്കൊരു ഡിജിറ്റൽ സിസ്റ്റത്തിനെ എക്സ്പ്ലെയിൻ ചെയ്യാൻ അതിൻ്റെ ഏറ്റവും ബേസിക് കമ്പോണൻറ്റ് എന്ന് പറയുന്നത് ഏറ്റവും സ്മോളസ്റ്റ് കമ്പോണൻറ്റ് എന്ന് പറയുന്നത് രജിസ്റ്റേഴ്സ് ആണ്. ദേ ആർ ദ പ്രിമിറ്റീവ് കമ്പോണൻറ്റ്സ്. സോ എങ്ങനെയാണ് ഒരു സെറ്റ് ഓഫ് എക്സ്പ്രഷൻസ് ആൻഡ് സ്റ്റേറ്റ്മെൻറ്റ്സ് ഉപയോഗിച്ച് നമുക്ക് ഇതിനെ ഡിസ്ക്രൈബ് ചെയ്യാൻ പറ്റുക, അതിനെ പറയുന്ന പേരാണ് രജിസ്റ്റർ ട്രാൻസ്ഫർ ലോജിക്. Okay, and the component of a digital system is actually described as follows: a set of registers in the system and the function, binary coded information stored in the register, the operation performed on the stored information of the register, and they are known as micro operation, and the control function which start the sequences of micro operations. So for describing a digital system, we need a set of registers along with the binary coded information stored in the register, operation performed on the stored information of a register, and the control function which starts the sequence of micro operation. Okay, so ഒരു ഡിജിറ്റൽ സിസ്റ്റത്തിനെ ഡിസ്ക്രൈബ് ചെയ്യാൻ രജിസ്റ്റേഴ്സ് ഏതൊക്കെയാണെന്ന് നോക്കണം, അതിൻ്റെ ഫങ്ഷൻസ്, അതിൽ സ്റ്റോർ ചെയ്തിരിക്കുന്ന ബൈനറി കോഡഡ് ഇൻഫർമേഷൻ. ഇനി ഈ ഒരു രജിസ്റ്ററിൻ്റെ മുകളിൽ പ്രവർത്തിക്കുന്ന ഓപ്പറേഷൻസ്, അതിനെയാണ് നമ്മൾ മൈക്രോ ഓപ്പറേഷൻസ് എന്ന് പറയുന്നത്. ഇനി ഈ എല്ലാ മൈക്രോ ഓപ്പറേഷൻസിനെയും കൺട്രോൾ ചെയ്യുന്ന കൺട്രോൾ ഫംഗ്ഷൻ. ഇത്രയും കാര്യങ്ങൾ ഉണ്ടെങ്കിലും മാത്രമേ നമുക്കൊരു ഡിജിറ്റൽ സിസ്റ്റത്തിനെ ഡിസ്ക്രൈബ് ചെയ്യാൻ പറ്റുള്ളൂ. ഓക്കെ, സോ ദ കമ്പോണൻറ്റ്സ് ഓഫ് എ ഡിജിറ്റൽ സിസ്റ്റം is described by using a set of register, binary coded information, and the micro operation along with the control function which starts the sequence of micro operation. So what do you mean by a micro operation? The operation that is performed on the data that is stored in a register. Registers are the smallest memory and they are used for data storage, and which all are the operations performed on the data. They are known as micro operations. It is actually an elementary operation and that can be performed in parallel during one clock pulse. And the result of this operation may be replace the previous binary information of a register. Examples for the micro operations include add, load, clear, move, shift, count, etc. are the examples for the micro operation. So a micro operation means an operation which is performed on the data stored in the register. It is known as micro operation. And what are the types of micro operations? We have interregister transfer operation, arithmetic operation, logic operation, and shift operations. Mainly 4 types of micro operations: interregister transfer, arithmetic operation, logic operation, and shift operation. What is actually interregister transfer? We need to move the data content of one register to another register, right? Moving the content of register to another register. That is actually interregister movement of data or interregister transfer. For that purpose, we are using some type of micro operation. They are known as interregister transfer micro operation. Next, we have to perform some arithmetic operation within a system, right? Arithmetic operations on the numbers stored in the register. For that, we are using arithmetic micro operations. And for performing logical and or etc., we need logic operations. And for performing some shifting in registers, they are known as shift operations. So the main four types of micro operations are interregister transfer, arithmetic operation, logic operation, and shift operation. Okay, first one, interregister transfer. Already said that interregister transfer is the function or the operation which is used to transfer content of one register to another register. Okay, for that purpose we are using a replacement operator. For expressing this interregister transfer, we are using a replacement operator, that is left arrow is the replacement operator, R2 left arrow R1, which means that R1 il ninnulla content R2 ilekku move cheyunnu. The statement denotes a transfer the content of register R1 into register R2. Okay, and the transfer happens in one clock cycle. The content of R1 does not change, but the content of R2 is changed. Okay, it is replaced by the new data that is coming from R1. So for representation of conditional transfer R1 to R2 by using P. P is a binary condition. If P equals 0 or 1 determines the transfer occurs, and the content of R1 is transferred into R2 only if P is 1. So if you are moving a content of register to another register based on some condition, how it is represented? By using the statement which is shown in the figure, that is P colon R2 replacement operator R1. P is a condition or conditional statement. Based on that condition, R1 is moved to R2. Content of R1 is moving to content of R2. Okay. The content of R1 is transferred to R2 only if P is 1. P is a binary condition. If it is equal to 1, then the content of R1 is moved to R2. So the basic symbols which is used in the interregister transfer, we can use letters and numerals to denote the register R1, R2, MAR, etc. And we can use parenthesis, it denotes the part of register. R2 0 to 7 means first 8 bits of R2. Okay. R2 of L means lower part of the register R2. That means parenthesis which is used to represent the part of a register. And the left arrow which is already denoted as a replacement operator. It actually denotes the transfer of information, right? R1 to R2 transfer is represented by using a left arrow. Okay, comma which separates two micro operations. If you have a micro operation or interregister transfer operation like R1 to R2, also R2 to R1, they are two micro operations, so they can be separated by using a comma. So these are the basic symbols which is used in a interregister transfer. Next we have arithmetic, logic and shift micro operations. First one is an arithmetic operations. As we had already studied that by ALU we can perform all arithmetic and logical operations, right? So for representing these operations, we have arithmetic operations as well as logical operations. Actually, a micro operation is an operation that is performing the operations on the data that is stored in the registers. So arithmetic operation, it actually perform arithmetic operations on a numeric data stored in the register. So first one you can see R3 left arrow R1 plus R2. What it means, the content of R1 is added with content of R2 and that will be transferred to R3. Same way R1 minus R2, content of R1 is minus R2, that will be transferred to R3. Then R2 left arrow R2 complement means the complement the content of R2, then it will be moved to R2. So these are the some of the arithmetic micro operations which is used in the system. Then R1 left arrow R1 plus 1. What it means? It's an increment operator, right? Plus 1, adding plus 1 to a particular content of register, which is equal, which means it's a increment operation. Okay. Same way R1 to R1 left arrow R1 minus 1 means it's a decrement operation. So the first type of micro operation is interregister transfer. Then we have arithmetic operations. After that we have logic micro operations. Why we are using this logic micro operations? We are using logic micro operations for performing some logical operations like logical AND or NAND, etc. So actually these operations are performed on the binary data that will be stored in the register. രജിസ്റ്ററിൽ സ്റ്റോർ ചെയ്തിരിക്കുന്ന ബൈനറി ഡാറ്റയുടെ പുറത്താണ് ഈ ലോജിക്കൽ ഓപ്പറേഷൻസ് എല്ലാം പെർഫോം ചെയ്യുന്നത് ആൻഡ് ഓർ നാൻഡ് എക്സോർ എക്സെട്ര. Okay, for that purpose what we are using is logic micro operation. Clear? So these are the list of micro operations. Logic micro operations. F left arrow Z means the F is clear function. F gives A and B means A and B, and is the logical operator. A and B not is the complement of B not is the complement of B. Okay. So some of the logical operations are AND, exclusive or NOR, exclusive NOR, complement B, complement A, etc. are the examples for the logic micro operations. So next we have a shift micro operation, and this shift micro operations which is used for serial transfer of data or for shifting the data content within the register. We have three types of shifts, that is logical shift, circular shift and arithmetic shift. First one, logical shift. Actually logical shift is one that transfers 0 through serial input. We will adopt the simple SHL and SHR for representing the shift left and shift right. So logical shift, circular shift, arithmetic shift. ഇതാണ് മൂന്ന് shift micro operations. അതിൽ first one logical shift. അതിനു വേണ്ടി യൂസ് ചെയ്യുന്ന representation SHL and SHR. SHL R1 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ R1 രജിസ്റ്ററിലുള്ള കണ്ടന്റിനെ ഷിഫ്റ്റ് ലെഫ്റ്റ് ചെയ്യണം, 1 ബിറ്റ് ഷിഫ്റ്റ് ലെഫ്റ്റ് ചെയ്യണം എന്നാണ്. SHR R2 മീൻസ് R2ലുള്ള കണ്ടന്റിനെ റൈറ്റ് ഷിഫ്റ്റ് ചെയ്യണം, 1 ബിറ്റ് റൈറ്റ് ഷിഫ്റ്റ് ചെയ്യണം എന്നാണ് പറഞ്ഞിരിക്കുന്നത്. എന്നിട്ട് ഇവിടെ തന്നെ സ്റ്റോർ ചെയ്യണം, R1ലും R2ലും തന്നെ സ്റ്റോർ ചെയ്യാം. ഓക്കെ, ദീസ് ആർ ദ ടു മൈക്രോ ഓപ്പറേഷൻ ദാറ്റ് സ്പെസിഫൈ 1 ബിറ്റ് ഷിഫ്റ്റ് ടു ദ ലെഫ്റ്റ് ഓഫ് content of register R1 and 1 bit shift to the right of the content of the register R2. So you have a data 100111000. So adine left shift cheyuka ennu parnu kazhinjal you can see left shift cheyidu 0 will be added at the rightmost end, പക്ഷേ ലെഫ്റ്റ് മോസ്റ്റ് എൻഡിലുള്ള 1 ഡിസ്കാർഡ് ചെയ്തു, 1 ബിറ്റ് ലെഫ്റ്റിലേക്ക് ഷിഫ്റ്റ് ചെയ്ത് പോവുകയാണ് ചെയ്തത്. ഓക്കെ, നെക്സ്റ്റ് വി ഹാവ് എ സർക്കുലർ ഷിഫ്റ്റ്, ഷിഫ്റ്റിംഗ് in a circular manner, that is circular shift. We have circular left shift as well as circular right shift. For that we can use a simple CIL and CIR. Okay, so CIL R1 and CIL R2, you can see right shift ആണെങ്കിൽ 1 bit right ലേക്ക് ഷിഫ്റ്റ് ചെയ്ത് പോവും. LSB പാർട്ടിലുള്ള ലാസ്റ്റ് ആ ബിറ്റ് ലെഫ്റ്റിലേക്ക് ആഡ് ചെയ്യും. യു ക്യാൻ സി സർക്കുലർ ഫാഷനിലാണ് റൈറ്റ് ഷിഫ്റ്റും ലെഫ്റ്റ് ഷിഫ്റ്റും ചെയ്യുന്നത്. Okay, for that two symbols are used or two notations are used, CIL and CIR. CIL stands for circular left shift, CIR stands for circular right shift. You can see circular left shift, left ലേക്ക് ഷിഫ്റ്റ് ചെയ്തു, most significant leftmost bit, the 1, that will be added to the right end. That is actually circular left shift. Next we have a arithmetic shift. Arithmetic shift is a micro operation that shifts a signed binary number to the left or right. Arithmetic right shift divides the number by 2, and left shift multiplies the signed binary number by 2. Arithmetic shift must leave the sign bit unchanged because the sign of the number remains the same when it is multiplied or divided by 2. Actually, this arithmetic shift is used for the division and multiplication operations, and the right shift actually divides the number by 2, and left shift it multiplies a signed binary number by 2. Arithmetic left shift corresponds to binary multiplication by 2, and next one arithmetic right shift, which is equal to the division operation by 2. Okay, so arithmetic shift must leave the sign bit unchanged. Leftmost bit, most significant part MSB part എപ്പോഴും അവിടെ തന്നെ remain ചെയ്യുന്ന procedure ആണ് arithmetic shift okay, because it represents the sign of the data. It will remain unchanged if we are doing a multiplication or the division operation. So you can see original data 100 after shifting the MSB part has remain unchanged. Okay, again it's a left shift. Next we have other part of a module, that is what I mean by conditional control statement. We had already discussed the types of micro operations. Next we have a conditional control statement, because we have to, it's a statement which checks the condition. Based on that condition, a particular statement is running or executing. So a conditional control statement is actually symbolized by an if then else statement in the following manner. So P, that's a conditional statement, colon, if condition, then a particular micro operation, or else a particular micro operation. So if then else statement is represented by using a conditional control statement. If the condition is true, then you have to perform a particular micro operation, else you have to perform this type of micro operation. That is the meaning of conditional control statement. Okay, so this is an example for a conditional control statement which can be represented by T2. It's a simple colon, if C equal to 0. C equal to 0 is the condition. Okay, then F left arrow 1, else F left arrow 0. That means based on C, if C equal to 0, then what we have to do, or which micro operation we have to do, is 1 will be transferred to F register. Else, if C equal to 1, what is the micro operation? F left arrow 0. 0 will be moved to F. So this is an example for the conditional control statement. You can represent any number of conditional control statements within a system. Okay, so these are all about the first part of the module 2. That is what are the micro operation, what are the types of micro operation, and conditional control statement. Okay,